Good morning, everyone. Thanks ever so much for coming in this early slot on a Thursday. And I know how fatiguing these conferences can be, so great for you all to be here this morning. I hope I've got an interesting talk for you. So, my name is Andy Wigley. I am a senior software development engineer in our developer experience group, DXTED. I specialize in Windows app development and UWP in particular. And a bunch of other stuff as well. DXTED, we do deep technical engagements with customers, a lot of early adopter stuff. But I also do a lot of this communication with developer community and showing you cool stuff, hopefully, and inspiring you, and so giving you some ideas about new ways you can do things. Now, there was two names on the agenda outside on the notice board. Vikash was going to be here, but he apologizes he's not, so it's just myself. And this talk is about some new ideas for having apps cooperating with each other, how you can kind of componentize a collection of apps and build an ecosystem of apps to all working together, and the benefits that you can get from that. You know, I don't know if you kind of recognize this. This is a kind of a, I kind of was trying to think, how could I represent this? You know how these things go. You start off with an app, and you have a nice, beautiful little thing that's nice, and it does a nice job, and then somebody else says, oh, that's good, but it'd be really cool if it did this as well, and you add this bit onto it. And then somebody else says, yeah, but what about this? Bolt this on as well, you know. So you go, yeah, okay. You try and please everybody, of course. And so you keep building this thing up, and then, of course, you end up with a bit of a monster. And it's very impressive, you know, and in its scope and its ambition, and it's kind of trying to do all this stuff. But you know how it goes with this thing like this. If you then want to change a bit of it, you suddenly find you've accidentally introduced all these interdependencies, and the whole thing turns out to be somewhat of a brittle edifice. And you can easily break things and have side effects and this sort of thing. Now, of course, good software engineering practice can address a lot of these problems. And if you're doing good patterns, software patterns, and creating nice components and plugging them all together, then you can obviously alleviate a lot of these problems of having this all singing, all dancing, do everything kind of application. But actually, you still got this big thing that you've got to test and deploy all at once and this sort of thing. Wouldn't it be much better to have this kind of functionality composed out of a lot of separate cooperating parts, which actually just happen to be apps, but they have specific roles to play? And you can think of apps really as another metaphor for components. Just some of these apps have a bit of UI, and some of them don't. They run in the background, but you can just work on them in isolation. They are nicely, on their own. They have a specific singular piece of functionality to do, and you can test them and deploy them separately, and they all cooperate together. Wouldn't that be a good thing? Well, this talk is about building those kind of scenarios where you've got some things that all plug together, all different components that are working together to achieve a greater goal. So, why would you want to do this? Well, a few reasons for this. You can actually have one app that is singular to a particular purpose, and that could be reused and shared across a number of different apps. Don't reinvent the wheel all the time. If there's a good app out there that does what you want, and it's been built for extensibility, for people to link into it, for it to perform a task, then use it, and you can actually, if you're an enterprise, you're building a suite of apps, you could do that as well. You could build a particular bit of functionality, and it could be shared across different apps. Maybe it does an authentication role, or maybe it does some particular processing that's associated with something that is common to a number of your different tasks that you want your workforce to do. And if you're doing this, if you kind of get into this mindset, you can end up with something that's easier then to extend. As you'll see as I walk you through these samples, the interface between these different apps is super lightweight and super flexible. And it allows you to very easily dream up new things you can plug into it. And the interface is handled by the system for you, and it's nice and clean, and it's very easy to plug in existing services and plug in additional things and extend things. And you can also, I'm going to show you something called App Extensions, which is a brand new technology we've just released in the Windows 10 Anniversary Update, SDK. And this is a way of actually also having an existing app and plugging in extensions to it. Now, the obvious example of this is the web browser. So modern web browsers can have extensions plugged into them to do ad blocking or password management or these kind of things. So we have built that into the Edge browser, and it's, of course, available in browsers from other suppliers as well. And the technology we have used to do app extensions in the Edge browser actually works just great with apps as well. So I'll show you how that works and give you an idea of the power of that. And actually decomposing complex systems into a lot of separate cooperating parts just makes sense from a maintenance point of view. I work closely with a large telecoms provider in the UK, and they have a huge application that's crucial to their workforce. And they reckon that they spend 80% on their time on maintenance of this thing and only 20% of their time actually building a new functionality. And that's the nature of it. It's crucial to their business. They can't afford to accidentally break it. But they are moving towards this idea of decomposing it into a lot smaller cooperating bits because it just reduces the risk and the costs from development and maintenance and developing new features. So plenty of reasons for doing this. The specific techniques I'm going to talk about here are these. So first of all, we have a thing called app handover, which is actually often known as protocol associations. So this is the idea where one app just simply passes control over to another app for either as a one-shot, here you are, you do something, or as a launch for results. So you launch the other app, it does some processing for you, and then it calls you back with the result. And the point here with app handover is you are launching over from one app that has some UI to another app that has UI as well. The next one is app services. Now, app services is very much like web services, but it's actually on device. So they are local web services, if you like, but they're available on the device. And you can build app services and ship them separately, and people can invoke an app service, run it up, and then communicate with it. And we have a very lightweight messaging protocol, two-way messaging between the calling app and the app service. And so this is a nice way of getting some good sort of background processing going off on your behalf, but in a reusable, in a componentized, in an app service, in a web service kind of model. That one doesn't have any UI, although it can still throw up toast notifications and tile updates, that kind of stuff, but it can't actually pop up anything on the screen as a UI. App extensions, I already talked about that one. This is a way of, for an existing app, you can ship, with another app, you can ship some content that the first app can then consume in some way, and that's pretty flexible as well. This is the technology that the Edge browser extensions uses, and I'll show you how we can make use of that in an app as well. And then I'm going to finish with a look at Project Rome, which is actually a really exciting project. This is extending a couple of these ideas, but running across different devices. So this is across remote devices. So let's drill down a little bit more into these. I was talking about these. So here we got an idea. We've got our original app with app handover, and that's going to completely launch another app. Now, if you do that on a phone, actually, it looks like you've just navigated to another page because they just run full screen. And also, if you're on a tablet, in a tablet mode, it just launches the other one full screen. And when the user is finished with it and the results are ready to be passed back, then it just simply calls back to the originating app. So there's this nice handover going off. But they are separate apps. They're cooperating. And this is one launching another app and waiting for results. And the app services one, I said that here we go. We start with our original app. And this time, it stays the UI app. It stays in the foreground, but it calls some background task that is actually hosted either by itself or by another app anywhere on the system. So this is the app service model. The app service does some processing, and when it's done, you get some results back. But the calling app stays in control of the UI for the whole period of this. This is called inline task handoff. The app extensions one, this is where our app is, again, the foreground app. You have some functionality, some basic functionality built into the app, but then you can ship extensions that can then extend the capabilities of that app, maybe add some additional photo filtering capabilities or some filters to photo processing or some additional data or even, actually, as I'll show you, as another cute way of exposing a background task. And that's managing and bringing in additional content. And the Roam one is the first two of those, not the app extensions one, but it is the app handover idea. But that one is, this is actually over different devices. So the other app is launched on a different device. It's one of your devices, not just any old device. So there is, as you'll see, it's associated with an identity. And then the other one is calling an app service, but actually that remote app service is run up on a separate device that the original app is running on, but obviously is contactable either through proximal messaging like Bluetooth or through the internet, through cloud. So those are the ones we're going to look at. And the example app that we're going to use, we built this for our build conference, and I'm going to reuse it here because it's a great example of this. And actually, it's a very simple photo processing app. And the idea is that you can open up a photo, do some photo editing on it, and then you can sort of save the result away. And we're going to extend the capabilities of this app using these different techniques so you can see how it all works out. So let's start off then with the first of these, app handover with protocol associations. Let's start straight away with a demo. So here is our application, and you'll see it's a very simple one. But I'm going to first of all hit this crop button, and this is the I'm just going to go and select a photograph. Let's go and get this one. This was actually a photo taken on a jam band. If you're going to the party tonight, I think there's a jam band on there. I might be tempted to get up and play a bit of bass guitar or something. And so what's happened here is this app is actually the built-in Windows 10 Photos app. It is the Photos app. The Photo app has some image processing capabilities built into it, including cropping of photos. And we have launched the Photos, the built-in Windows Photos app here. And obviously, yeah, I can do a bit of cropping there, we can actually, then we say apply, and we're going to send that image back, and rather out of focus, but there's me strutting my stuff on the stage at a conference in Seattle earlier this year, which was a lot of fun. So let's have a look at how that actually happens. So this is the code for it. The crop click, this is the event handler that fired when I hit that crop button. The first bit of it, the file setup, is we call the file open picker API, which just puts up the go and select the file. So this is one where I go and selected the image file. Then once we've got our file, then I call this method just down below, which is crop image async. So here's crop image async, and there's a couple of interesting things happening here. First of all, there's some APIs in the UWP called the Shared Storage Access Manager. And this is useful for passing a token for a file across to some other app. So you could actually ship the whole bytes. You could serialize the bytes and send all of that over the connection to the other app. But no, it's a much better idea to just get a token using the Shared Storage Manager, Shared Storage Access Manager. You get a destination token, and then you can send that off to the other side, and the other app can redeem that token and get access to the file. So that's real nice. Now, we set up some launcher options, which we're going to, here we are. This is the package family name. This is the actual published name of the Microsoft Windows Photos app. That is what it is known as in the world. Its unique name. And then when you want to send some data across, you'll see this repeated over and over. We use this very nice lightweight object called a value set, which is just a string value dictionary. That's all it is. And you can put anything serializable into that dictionary. And here we are. We've got our value set, and we're just poking in some key values and values. So there's the file token. We've got another token. This actually is what we're going to get back from the other side. We give some the actual initial width and height we want for the cropping UI on the other side. You could select an elliptical crop if you wanted to. And then this is the API that then launches the other app. Launch URI for results async. There's actually two flavors of this. There's launch URI async, which just is a fire and forget. And launch URI for results async launches the other app in a kind of modal window. So the first one is sitting there in the background, and it will wait until the other app has finished what it's doing and sends back. It actually sends back a response to this app. And when that response comes back, this awaitable method will complete, and we will get back in our parameters the token to the changed file. Now, what then happens in this app is quite simple. All we do is we load our destination image. There's our dest. We get our file back again. We read it in and just show it on the screen. So that's what happened. Now, this, the way that the other app actually declares for a protocol is it puts in its manifest a fake URI. So in actual fact, when we call the launch URI for results, this is the URI, microsoft.windows.photos.crop : whack whack, is a made-up URI scheme, just as HTTP is a proper URI scheme. This is a made-up URI scheme that this particular app has registered for, and it just declares it in its app manifest, says, hey, I know about Microsoft.windows.photos.crop requests. And anybody can launch it. In fact, you can go into the Edge browser, you can put Microsoft.windows.photos.crop : whack whack, and it will launch out to the app. Any of your apps, you can just cook up your own protocol scheme, and you can use URI launching in order to launch another app. And this is the technique that we've used here. Let's dig a little bit deeper into the code that makes that happen. So that was the demo. We added photo cropping to our photo editing. So there's a few APIs that you can use with this that are of interest. First of all, if you want, you can first of all, when an app is installed, like the Windows Photos app is actually out of the box. You get it with Windows 10, it's there. But your own apps may or may not be on the device. So the target app may not be on the device when you call launch URI for results async. So you might want to just check on the system whether the target app is actually there or not. And you can do that with this query URI support async API call here, where it's just saying to the system, hey, you know, I want to know if sample.uwp app B package family name and the URI app B for results : is on the system. So just a point about that. Obviously, the URI scheme, you can't reserve a URI scheme for your own dedicated use, but your package family name is unique to you, to your app. So what you were doing here is searching for a combination of a particular URI scheme offered by this package family name. So that way you know that you're going to the intended target and not that some other app has hijacked it. They can't do that. So here we are. We're just asking whether it's available or not. If it's not available, you could put up a bit of UI saying, hey, this app's not available, so here you could go take them to the store. You'll need to install this app to complete this task. Or if you're in an enterprise scenario and you're side-loading apps, then you pop up a UI and give them some help about how they can then go and install the target app that you need. So, and then once you have got, you know that the actual app is on the system, then this is the basic code. We saw this a little bit in the sample there. You set up your launcher options with the target application package family name, and then you simply launch that URI, and the system will take care of launching up the other app. And thereafter, you send it some data in a value set, and then on the other side, this is where the other app has finished. So in other words, with the cropping thing, I clicked the OK button. Then it calls protocol for results operation .report completed, and then control passes back to the originating app. So why is this a good thing? Well, it's really, really lightweight, very easy to implement, nice and easy. You can pass anything in the URI. You can pass data in the value set. You could also pass data in the query string. It doesn't matter. You can use either of those things. It's the protocol bit that's important for launching the target. But so it's a real nice, easy way of getting data over there. And it allows you to reuse existing apps instead of rebuilding functionality and over and incorporate the same old stuff into multiple apps and then you've got the problem of keeping them all up to date and synchronized. You just reuse instead of rebuild. And you can also use it to create a couple of apps that, you can actually use it for promoting apps where one is adding value to another and saying, hey, my photo editing app offers cropping capabilities. Please, link to it and use these capabilities, which obviously drives adoption and usage of your own app if you're offering these services. So lots of benefits from that, nice and easy and lightweight. Okay, so that was that guy. The next one I want to talk about is app services. So app services here, this is the next one we want to look at. So we're going to go straight to the demo again, show this in action. So here's our app. Now I'm going to open a new image. Let's go and get something else out. Went for a nice hike recently. There's a tree. Lovely tree. Okay, so now what can we do with this? So you've seen the crop thing working, but the grayscale one, I'm going to click this first, and first of all we get a pop-up saying you need to install another app to perform this function. Take you to the Windows Store where you can install the app you need. So this is where you would redirect to whatever method. I haven't actually implemented that bit. But the actual app service app isn't installed on the system. And so what was happening there was let's have a look at the grayscale click event in this same application. And here we are. This is where you're trying to make a connection to an app service. You new up an app service connection object. You specify on the connection the name of the app service, and again, the package family name of it, so the unique identification of that particular application. And then you try and open a connection to it. And that would fire up the app service and cause it to get launched and do your stuff. But you get a status back, and this is where we're checking the status. If you can get a status back saying app not installed, which is why at that point I popped that message dialog up, the one you saw there. But if the app is installed, then we can carry on and use it. So let's just go over to another project where I have got that app service is declared and installed. This is the project, Grayscale Image Extension, and it consists of two actual projects in it. We've got a foreground app, which actually doesn't do anything. It hasn't got any UI. In a real app, you probably would create the app that is hosting the app service would probably be a client of the app service itself. That would make perfect sense. In this little example, there's nothing there. So all of the functionality is in this background task here, which is a separate project. And here is the logic inside our app service, which is going to be called in order to do this operation. So this is all our logic. This is the logic to do grayscaling. And I'm just going to deploy the solution to my system. And that's deployed now. I don't have to run it or anything. It's now on the system, so the Windows knows it's there. And now when I hit grayscale, it's going to launch there we go, and we've got our result back, and it's grayscaled the image. So the app service has worked silently in the background. It was actually hosted by a completely different app, so you can ship updates to the app service separately. Like I said, the interface is just basically pretty similar to what you saw with the launch URI. So go back to the grayscale, and let's dig a little bit deeper into the code here. So when you launch, first of all, how does an app declare that it has an app service that it can offer to the world? Well, in the package.apex manifest, here's the Apex manifest. I'm looking directly at the XML here. This is the app that hosts the app service. And you'll notice here we've got an extension declared of category, this one, sorry, Windows.app service. We're going to come to that guy in a minute. That's the app extension. So Windows.app service. And the entry point is grayscale service.service, which is a class that is in that background task. And there's the app service name, com.microsoft.grayscale service. And the package family name for this guy is the the identity is declared at the top. In fact, if I just open this up in the GUI editor, you can see a bit more easily under packaging. There's the package family name shown to you, app_extension.extension.grayscale, and then the magic number at the end. That was what was used in the client to identify which app service it wanted to launch. And then back in the service, this is, like I said, it was the entry point was grayscale service.service, which is a class that inherits from, implements iBackground task. This is the definition of an app service. And an app service always has a run method, which is what gets launched. This is the method that is the entry point when somebody invokes your app service. So this is the first bit of code that runs. Now, we're going to do some async stuff for the first, so you get a deferral, so you can do some async calls. And then this is the important things here. First of all, you would hook up on the app service connection object, which you get in this task instance. Task instance.trigger details that's passed in includes the app service trigger details. So here you would you hook up a request received event for that app service, and thereafter we're just into a asynchronous messaging essentially. So this will fire every time the client sends a data message to it, and it can just send them asynchronously. It's not like request response or anything. So this will fire whenever a request comes in, and obviously when it's first invoked there will be a message on the initial launch, and then we are passed in the message details, another one of these value sets. So this is our message is our incoming value set that's been sent from the client, and we are newing up a return data, which is going to be the one we're going to send back. Now, typically, this is completely, a value set is just a dictionary. So the protocol you come up with is entirely up to you. And typically, the convention is that you will have a command in the dictionary, which is instruction to the service so you can have different tasks that it can perform to you. This one is grayscale or load, which actually both of them do the same thing. They call the grayscale byte array method and return the data back to the caller. And this is where we send a response back to the caller. And this can go on. The app service will stay alive for as long as the client is alive. If the client is terminated or the client is suspended, then the app service dies. So its lifetime is tied to that of the invoking client. And if two clients call the same app service, well, then there'll be two instances of that app service running. The grayscale byte array is just a bit of code that actually does the grayscale stuff. So that's essentially the guts and the way that an app service actually handles. Now, on the client side, let's have a look at the client over here. Then this is, we already were up to this point, and now this is where we have got a connection to our app service because we've installed the app now, and this is the client side. It's making up a value set, and then we just send message async. Now, the client, in this case, just waits for the response to come back, which is the grayscaled image. But this, actually, the interesting thing about the flexibility of this is that with this app service connection object that the client has got, it could also attach a message received event handler. So both sides can send messages asynchronously. There's no kind of request response going on. Both of them can kind of send anything whenever they need to talk to the other side. This is handling the message that's coming back in, and we get our new image, and we simply stick that up we encode it, and we stick that back up on the screen. So that's the app service one. Nice and simple, very flexible. And this has been around actually since I think it was the first release of the UWP, and we've been extending it with some of the other features here. It's proven to be quite a popular way of creating these background tasks that are callable from one app to another. So just to reiterate, just to go over the key technical features here about this thing. So the point of app services is that one store app can provide services to other store apps. or enterprise apps, UWP Apex apps. So you can have, one client app A could create an app service connection over to the app service hosted by app B, and it just invokes it. And like I said, its lifetime is tied to that of client app A. If client app C wanted to call the same app service, it gets its own unique connection and its own instance of that app service. And the code to do that, you saw that you get an app service connection on the client side. You specify the name that is declared for that app service and the package family name, and then you open a connection to it. And you just send value sets across, and they do stuff for you and send it back, nice and flexible. There is another query API, rather similar to the launch URI, the protocol associations, where you can also find out whether that is there. And this is the app service catalog.find app service providers async method. And there you can just find out if there are any apps on the system that are already installed that declared, and do the similar thing. You can do some action if that app isn't there in order to get the right thing onto their system. On the client side, we saw this. This is what goes in the manifest. You just declare a Windows.app service with the entry point into where the task is implemented, and you give it a name with the UAP app service. And then you implement it. So here we go, and this is a public sealed class that it just needs a class that implements iBackground task. Now, actually, as you'll see when we get to Project Rome, one of the more interesting features of the anniversary update is that your app service now doesn't have to be in a separate project running in a background task. So the model until the most recent update was that it would have to be in a separate project. It was a WinRT component project, and it would be run up by a separate app service host process on the device. It can actually be in the same project as the foreground app now. So that has very interesting. We get to Project Rome, we can do something really interesting with that. But the point is the class must implement iBackground task and must be the entry point must be declared in the manifest. So that's the key for saying what an app service is. And then we connect to it on the client. We new up an app service connection, we connection.openasync, and we check the status to find out whether we've got it, and then it's just value sets going across the wire. Real nice and easy. So what's the benefits of this? Well, this is the ones where the called app service doesn't have any UI, but so you can just have some background execution, some code that works away for you, and it stays within the context of the invoking app. So the invoking app controls the lifetime. It's just got a nice service that it can call to do some processing for it. And the app-to-app messaging is the value sets across, and it's completely asynchronous, two-way messaging available there, so it's super flexible in what you want to implement. And also actually works across devices using Project Rome, and we'll get to that in a while. Just a little bit to confirm that app service lifetime. The service is activated on demand and persists for the length of the connection. The client may terminate the service by disposing of its app service connection object. Or if the invoking app is suspended or terminated, of course, then those app services sponsored by the app will be terminated. The other thing that could cause a failure is if the system is under stress, memory stress, or whatever, the system may decline to launch that app service. And obviously on the client side, you'll get a failure status return back from trying to make that connection. So that was app services, which is the second one of our three key technologies. Next one of our cooperating technologies is app extensions. So the app extensions is first of all, before I go straight to the demo, I just like to do things a little bit differently. So first of all, we have two sides, of course, to this. There is the host. There is the app that hosts the app is the original app, the one that is being extended. And that is the app extension host. So it's an app that can host app extensions. And you declare the kind of, this is also super lightweight, super flexible. The only thing that declares what this extension is, what the interface is a string name. And it's actually up to you to document what that means, how an extension, what the extension must be and what it must offer in order for the host app to be able to consume it. So you can kind of think of this idea of you're kind of trying to build an ecosystem. You might be a Facebook or something, and you want to allow people to build extensions to extend Facebook to do something else and other things. So, but you declare the name. In this case, we've got a name that is PhotoX. So you're declaring to the world, OK, I'm going to accept PhotoX extensions. Now, the other side of things, that is, on the other app, people can then produce apps that include within them app extensions. And in their manifest, they declare that they have a Windows.app extension. I've got an extension for you. Now, the name of it must match the name of the host app. So it's PhotoX again. But then there's a couple of other things in here. The public folder, this is a folder in the app where there's some stuff that the host app can consume. And that stuff could be anything. It could be, as you will see, it could be some JavaScript files. It could be some static files. Could be JSON. Could be images. Could be all sorts of stuff. And then you give it a name and a description, and then the originating app can consume it. All right, so let's have a look then, before we talk a bit more about the bits and bytes of it all, how that works. So here we go. We are in our app still, of course, and we've just done our grayscale and our crop. Now, actually, you remember that grayscale wasn't, I clicked it before and nothing happened because the grayscale app wasn't installed. Now, I've got another tab in this app called extensions, which lists the currently installed extensions into this app. So this is just the same as the Edge browser. You can see what browser extensions are currently installed into the Edge browser. Now, in this particular case, we have got something called a grayscale extension is installed into this app. Now, that grayscale extension is actually hosted by the same grayscale app that has the app service on it. And the reason it's listed on here, you don't have to have the two together. It's just incidental. In this particular sample, this grayscale app actually employs both. I'm going to come back to that, but before we go into do anything else, I'm going to install another app. Let's see. Let's keep this guy running. Let's go over to. I'm going to start up a new instance of Visual Studio. And so in my sample code here, let's start the invert image extension. I'm going to install that. Here we go. It's the solution file from Visual Studio first, but and we'll just let that run up. Here we go. And actually, I'm just going to dock that over on one side, and I'm going to keep my app over on the other side so you can just see what happens. So the app is running, and over here, I'm going to deploy, if I can figure out how to find the bit with this weird, here we go. Just deploy it. So we're going to build it and then install it onto my system. Not running it or anything, I'm just going to deploy it onto the system. There you go, an invert's just popped up onto my extensions tab. So the app has dynamically been notified that a new extension's been installed onto the system. Let's go and open another project, which is another one in the similar place, which is the rotate extension. So I've got another one here. This one just for interest. Project. Store. I'm going to build an app package as if we're going to create app packages, as if we're going to ship it to the store and do it through the store. But I'll just build them locally, create the app package here. and I'll just build it, and it will construct my package for me, just for variety's sake, just to show how we can do this. So you can imagine then, so we can go off to that location, and if you look at the, let's close that, and I'm going to go to x86. Let's install this package here. I've got the blue donut of death. Come on. The idea was there, I was going to right-click and run this with PowerShell, and it's just frozen up on me. Ah, disappointing. Well, look. I'll just let that sleep a little bit. No, let's go back. You see, we got these. I can enable one. I'll do this in a minute when it comes back. I can enable, back in the app, I can enable that extension. So if you tick them, that's enabled. And actually, the way this app is written, when extension is enabled, we get a new button on there. So I can actually click invert, and that will go off and invert my image. So there we go. We've got a nice inverted tree now. Let's see if the rotate extension is back with us. Do you know what? I'm just going to deploy it. I'm not going to try and do it through the app package. Let's just deploy this guy as well from Visual Studio. That's deployed. And back in here, we can go back to our extensions. Extensions tab. There we go. And that one, the rotate one, has two app extensions included in it, that one app that I've just deployed. And so I can select enable these as well. In fact, let's enable all of them. And then we'll go back to here, and you can see now we've got actually two grayscales. The reason why there's two grayscales is that guy was the one that directly invoked the app service, and this one is invoking the same functionality, but through an app extension. So these four are all from app extensions, and I can rotate it to the right, and there we go, and rotates to the right, and you get the idea. So and put it back again, and all this sort of thing. So we've added additional capabilities to app through app extensions. Now, what's going on here? There's actually a lot of interesting stuff to find out about here. So let's go off and minimize this and go back to kill that. That wasn't working very well. I want to go to I closed that one. So let's go and let's have another look at the Rotate Extensions project, because that's got some interesting things in it. Now, first of all, this is the app that obviously hosts these two extensions, the Rotate Left and the Rotate Right extension. So let's have a look at how that is implemented on the kind of delivery app, the one that's hosting the extension, how that's implemented. Okay, so first of all, in the manifest, let's have a look at the manifest in code, view the code of the manifest. Let's have a look at the XML. So we'll close it in there. And here we go. In the manifest, this is declaring two extensions. Here we go. There's the first one, and there's the second one. They're both Windows.app extensions. They have the name, build 2016 app extensibility.demo, which is the same name that our host app declares. Just to prove that to you, here's our extensibility sample. We'll go and look at this, the manifest. This is the app extension host, and that's the name that it says, I understand, build 2016 app extensibility.demos. So back to this, it has two app extensions. The public folder is, in this case, is public, and the public folder for the other one is called public2. They just have a name and rotate right and rotate left, and a description. So what is in those folders? Well, interestingly, in this case, the folders have in them some JavaScript. In this case, there we go, JavaScript. And that's one of the, this is the JavaScript to actually do rotate left and rotate left. So in this case, we've decided to implement this through JavaScript. Now, we're not sure we necessarily recommend this. It's a way of actually getting code dynamically invoked, if you like, by a client. So let's have a look at the client and see how that works. So this is, it's declaring it does that sort of thing. Now we have a file that is called extension manager. This is like a template file, and it's intended, it's in this sample, and you would just basically reuse this and make some minor modifications, because this has all the functionality you need in a host app to handle app extensions. The one reference is, it actually is called from app.xaml.cs, so when the app starts up, we initialize the extension manager, and we give it the name, build 2016 app extension delete.demo. And then in the constructor here, we just open the app extension catalog. So this API is drilling into the Windows knowledge of what app extensions are available on this system. So the app extension catalog, we open it, filtering it on that name. So we're only interested in app extensions that we understand, because obviously there could be app extensions for other apps in there. So we're only interested in that build 2016 whatever ones. And then a bit further down, we actually initialize this. So this method is called from from main page.xaml in this case. So we initialize our extension manager. And essentially, all we do here is we hook up a load of events. So we get notified by the system whenever an app extension is installed, is updated, is uninstalled, the package is updating, or if its status has changed. And then we call find all extensions. So we just ask the catalog, find me all extensions on the system that match the name that I'm interested in. And then for each of those extensions, we load them into the system. And essentially, this is just reading the data associated with each package. So we get the unique identifier for the package that's declared by the app that hosts the package. We check its status is okay, and we could do some signature verification, so we can do some more secure stuff there. And then we can get some extension properties. I'll come on to that in just a moment. And there we can get the logo, the image. And essentially what this is doing is building that list up that you saw on the extensions tab. So we're listing the extensions that we can find, and we load them in. Now, okay, so then we enable them in the UI. Once they're enabled, then we can use them within, and then the buttons turn up on the UI, and that's app-specific, of course. And we encapsulate what happens with an extension with this class here. This is custom to this class. And here, it has a bunch of properties which allows us to, this is where we load that extension. So here we are. This is us clicking the button, saying rotate left, and it is calling to the code, the package that is hosted by that app extension. So in this case, we are using the web view object, and we are invoking the script extension load that we found in that app extension. The comment there says it all. This is dangerous. There are security implications for this. So this is actually, although it works, this is not the best way of doing it. Let's have a look at the best way of doing it. So the better way of doing it is actually back in our grayscale. I said that supports two ways of being called. We already looked at calling the app service directly, but this also hosts, look at the code, also hosts a app extension. So this is the app extension. So first of all, the first extension in the manifest was declaring the app service that we called directly. But this app extension actually doesn't have, you notice that we have here, This is an app extension. It's got the right name on it. It has a public folder of public, because you've got to declare that. But actually, if we look at public, here we go. Well, there is an extension.html there, but so you can do it the same. We can do it the JavaScript way. But actually, what we've done with this one, we've declared some custom properties in here, and this can be anything. So this custom properties, we have given it this is the name com.microsoft.grayscale service of the app service. So actually, we're using app extensions here as a way of exposing an app service. So it's a different way of calling an app service, and actually is a better way, because when we invoke this, let's go back to where this is called. This is the invoke load. This is the one that does app services are a better approach for this. This is where we have got out of the properties. We got out of the package. When we loaded the package, we got that app service name. So here we can go and drop down into our app service code to call the same thing. But the interesting thing is the calling app kind of doesn't need to know what the package family name in this case. So this is the difference from calling the app service directly, where the calling app did need to know the package family name. In this case, the app extension effectively has given the host app the package family name, because it's in the extension package ID. It comes over when the extension is loaded. The caller can find the host can figure out what the app extension is of the app that's providing it. So it's actually slightly a different way of doing it. And of course, you get all these events. Let's just go back to these events things here. You see, we've got all these buttons here at the moment. And go back to here. We've got all these. Now, what happens when I uninstall one of these apps? Let's uninstall the Grayscale app. Uninstall it. It's gone. There we go. And it's gone from my list as well. So the app's it's dynamic. The app gets notified of this on its own. And actually, you can also, from within the code app, you can uninstall apps directly from the hosting app as well, apps that host extensions. So in this case, we are going to uninstall invert image extension directly from the host app, and that's gone. So you've got loads of flexibility with app extensions, all this dynamic notification of them being installed. You can get queries, you can pass custom properties, you can use it as a mechanism for going into to exposing app services. So it's super flexible and real nice way of extending existing apps as well. Good. So quick summary about that. This is the APIs that you need to know. That's the namespace app extensions. The app extension catalog, this is the thing that's hosted by the Windows system, where you can query it to find out what app extensions are available on the system where you're running. You can find the extensions that are there by calling find all async. And then you can get notified when a package is installed or indeed uninstalled or altered and that kind of stuff. And then when you are loading the content in the host app, you call get public folder async to get access to whatever it is the extension has put into that public folder. So yeah, both opt-in via declaration. It's super flexible. You have to actually sort of you need to publish a developer guide if you like. If you want to have an app that accepts extensions, it's up to you to communicate to people how that they must build their extension for it to work. Host provides the dev platform, but app extensions themselves are apps and can be shipped and maintained independently of the host. So it's another decoupling mechanism. All right, so we're on to my last topic now. And this is super exciting, super interesting stuff. Project Rome. Have any of you heard of Project Rome? No, nobody's heard of Project Rome. Good. Okay, Project Rome. Rome wasn't built in a day. So we've released our first kind of version of this. But this is the first two things, not the app extensions bit, but app handover and app services across devices. So this is really, really exciting. So the Project Rome architecture. Project Rome is the idea that when a user registers a device, they obviously register it under some kind of an identity. Now, at the moment, I will say this, a restriction is that currently this works with Microsoft accounts, MSAs. doesn't work with devices that are registered with corporate identity yet. But that is coming in a future update. But obviously, when it registers with a Microsoft account, obviously the cloud services, our cloud services know about that device. And another device, it's made this case a desktop, also registers with a Microsoft account. So if you're on a Windows 10 device and at some point you associate your Microsoft account identity with it, then we know about it. We know about these devices. Now, this is a valuable source of information. It's valuable to us because we can ship stuff to you and register them and get updates to you, and then you're plugged into the store system and all the apps updates and everything works. But it's also interesting for you as an app developer because you can make use of this information. So first of all, you can actually find out which devices are out there, and you can find them in a couple of ways. You can find them both by proximal devices through Bluetooth, or actually just over a cloud connection, so over a regular internet connection. You can find out where your devices are. And you can discover them, and once you've got that, then you can start exchanging messages and doing sort of launch URI stuff and that kind of thing. So yeah, remember launch URI sync? We started with this, which is the app handover one. So this is where your app declares a custom scheme of some kind, my app dot whatever. And that's your own custom scheme. And with that on device, you can launch URI sync, and that will just launch the app on the same system. And you saw that that's the one we started with. But the good news here is, using Project Roam, that this actually works across devices now. So you can make a remote system connection request to a remote system, which you've discovered from your device graph. You found the list of your devices. You say, OK, I want to connect to that one, please. You get a remote system connection request. And then you just simply use the exact same launch URI async API, but this time using this thing called a remote launcher. So it's doing exactly the same processing, but the launch actually happens. The app suddenly pops up onto the other device rather than the one where you're currently running. So that's kind of nice. Remember app services. That was the second technology we looked at. So here we go. Store apps can provide services to other store apps. Yep, we know all that. And this was the this is the local operation that we looked at. Here we got client app A is launching and communicating. You get an app service connection, and then you exchange these value sets. We saw all of that. But this also works where the app service is on a different device. And in this case, you actually create a remote system connection request. And you actually open a remote async connection to that device. And then after that, it's just the same. You exchange value sets across. There is a little restriction I'll come onto actually on this slide. So you can determine if you are an app service code, you can figure out whether you are being invoked remotely, but there's an is remote property that will be true or false, so you can figure that out. And in the manifest, if you want to allow remote invocations, you have to set is remote equals true in the manifest where you declare your app service. Here's the thing, but with those value sets, the messages across remote devices, the maximum message size is 64 kilobytes. So if you want to send more than that, you'll have to implement some kind of chunking mechanism in order to send. But since the messaging is kind of async, you can send multiple messages and then have the receiver, the app service, reconstruct it on their side. So now the demo for this, remote discovery and remote app services. OK. There is a sample app called, which is actually at http://aka.ms/romap. And the Roam app is installed on here. It's called the Roman Test app. It's in the store. Here we go. And I've just run it up. And this is initially doing the discovery of my devices. So this is running on my Surface Book here. And it is telling me that, hey, I know about these 5 devices. So these are the ones that I have registered at the moment. I'm sure there's more than that, to be honest. But the actual Oh, no, these are the ones it knows that are available, actually. So weirdly, the Lumia 950 XL is back in my hotel room. Well, it must be on Wi-Fi. Windows Phone, I have no idea what that one is. I have so many devices. And Lumia 950 is my own device, which is here. And Venue Pro is a tablet, which is also back in my hotel room. But desktop HBQP2BS, nice snappy name, is this Surface Pro 3 here. I haven't got Bluetooth turned on. It's saying all of them are cloud, so it knows about them through the cloud. And you can actually filter. You know, I can actually say, okay, I'm only interested in desktops. Or actually, I'm interested in Surface Hubs or HoloLenses or Xboxes or any of them. I don't care. Let's have a look at all of them. And then we can actually discover each of these devices. And the discovery type, you can say, okay, I'm happy to search through the cloud or actually only through Bluetooth. I'm going to stick with any. Now, I'm also going to dock you guy over there. There you go. And then I want to, I'm going to start up a remote desktop connection to my Surface Pro here. And put in the password. There we go. So this is the system next to me. And you'll see here, I have got in my UI in the Roman Test app, I have installed the Roman Test app on here. I will give you that. But the first one doesn't need any app on there because this first one I'm going to do launch URI async. This is launch UI across, hang on, I didn't actually select him, did I? So let's select him, desktop, here we go. I've selected my Surface Pro 3. And then I'm going to, let's go to msn.com. I'm going to launch the URI. And it should launch the browser over on the Surface Pro 3 in just a second. It's going to launch the browser in just a second. Oh, that's really not helpful. Come on. Go on, do it. Huh. Has it changed? No, it's reconnected. Stop practicing. No. Gosh. That's very disappointing. Hey, okay, so that one. So the browser didn't work, but I've just, that has launched. Okay, so I launched URI, so that worked. MS Windows Store, :// PDP, that actually is the deep link into the store for the Roman Test app, the Rome Test app. And I've launched this. This is actually on my, on my Surface Pro here. So it is up, and it has launched into the store app. So that was great. Edge didn't want to play for some reason. And this is the app. You can see, actually, it is already installed. I'm actually not going to run it up now. It's not running at the moment. Oh, it is. Right. Okay, that's me. Sorry. Yeah. So then let's park that one back here. Now, this is nice, though. This area down here. Oh, you can go away. Okay, so now I'm going to, over here on my desktop, I've got a pen here. This area here where it says clear at the bottom is actually an inking area. So I'm going to say, I'm going to write on here, hi Atlanta. And all right, let's do it a different way then. Let's do it the other way. Let's go over to my remote desktop here. Oh, hang on, it worked. Look, this is the app. Oh, right, okay. Not super. So this is the Roman Test app. as you can see, it's not being very kind to me at the moment. Let's, oh, I didn't mean that. Cancel. What I meant was Roman test app. Huh? Oh, man. I'm in tablet mode over here, which is confusing the hell out of me. So, let's do this again. One more time. Come on, baby. Right. So let me go to there. Right. Oh, thank you. So I'm going to let's do it try it the other way then. So actually, Bing did launch belatedly on the other one. Remote desktop connection. Let's go back again. I don't know the answer to that, actually, I'm afraid. This is the remote desktop. I'll have to find that out. I'll get back to you on that. The remote desktop connection here, Bing actually did come up eventually, a bit belatedly, and MSN, so it did get there. But actually, on here, I'm going to launch the Roman app on here. Here's the Roman app. Start it over. It's kind of difficult, this Roman test app. I'm running on. I'm actually running it on the Surface Pro here. Okay, that's my Surface Book, and now I'm going to write on this one. And it's now Roman is launched on my Surface Book, and the what you should see in a minute is that. Well, that's disappointing. So what happens normally is that the ink strokes appear onto this. So apologies for that. It is a test app, and it's not super robust, so it needs a little bit more hardening up clearly. So what actually is meant to happen up is the ink strokes turn up, and it works flawlessly until you try and show it to people. Well, what's really interesting, and the interesting thing about the code let's kill you. The code that's going on here is that this is the source for this application, and the actual connection, the ink strokes are sent over. So when we have a let's go look at my. When we collect some strokes, two things are happening. So what's meant to happen is it launches the remote app on the other system. You did that, you saw that. And then the ink strokes are supposed to appear up on the screen as well. It's probably suffering a bit with the network. I probably should have gone on Bluetooth, and it might have been a bit better. But what actually happens here is an interesting thing, because it's using both launch URI sync and app service together. Because when you get some strokes on the originating app, if we get more than 2 ink strokes, then we launch remote URI async to launch the app on the other system. And then separately, once the app is launched, we send the ink strokes over to the other system via an app service. Now, this is kind of interesting, and I said at the beginning, what was interesting about this is an app service normally runs in a separate host in the background, and an app is actually running as the URI separately from that, and the two don't actually really connect. But in this case, because this Roman test app is implementing a background task in process, they are actually running in the same process, which is something you can only do with the anniversary edition. And then when the ink strokes are gathered, received, then it fires an event which the unupdated ink data. So the background task fires an event, says, hey, I've got some ink strokes, and it sends it to the UI, and the UI then draws it on the screen. Except it didn't work terribly well there. So that was a bit of a train wreck of a demo, and I apologize for that. This is an emerging technology. What this is exciting about, and where this came from, was the Xbox remote control thing that we had. So you can actually sort of use a different device to launch a message to other devices. So you can actually, when they're proximal, you can cause things to happen on devices that are near to you. So you can do things where an app can hand off to a different device. You could be watching a video on one device and then continue it on a separate one. You could actually have these companion experiences, like the Xbox companion sort of thing, where you're offering additional things happening on a device that are related to something that's happening on another screen. And you can actually do remote control as well from one device to another. So lots of interesting scenarios for this. So that was all the different app-to-app extensibility. A number of things I showed you there. There's protocol associations for lightweight app handover, app services for background message passing and making apps work better together, and app extensions, which offer all these interesting APIs for dynamic discovery and management to connect and share content. And then, of course, both of these can be used with Roam to work across devices when it behaves. So all of these together, you can use these to build an ecosystem of cooperating apps and componentize things and get the benefits of that from reduced interdependency and lower maintenance costs. That's what I had. Please, if you wouldn't mind, I could encourage you to give evaluations for this session. We really appreciate your feedback. And for other sessions that are still to be held at Ignite in the Windows 10 developer track, there's a number happening today. There's security with Windows Hello for Windows apps and Edge websites coming up in the next session slot. Dive deeper into the Windows Store for Business, the Windows information protection for keeping work and personal data separate, and then optimizing Windows apps across screens with Continuum. And then tomorrow morning, my friend Jerry Nixon is doing a great session on pen and ink for the enterprise, and then about distribution of apps with the Windows Store for Business. We also have some theater sessions, and if you come to the expo, please come and talk to us down there. We'd love to continue the conversation, and you can get additional resources from there. Thanks very much for attending this session. I'll take any questions if there's anybody who wants anything, any more clarification on anything I've covered. Thank you very much.